Hello everyone, welcome to Biophysics. This will just be our little introduction into how this course is going to be run, and currently just checking to see if Blackboard Collaborate is all set up just fine, and yeah. Alright, well everyone, I understand that your orientation is actually Thursday, so most of you will probably see this after it's already recorded, and that's okay for recitations. Let's see, just as a little introduction, this is Biophysics. This course will just be offered online, and you're just going to have a lecture component. There is no laboratory component. I'll be the one staffing it. My name is Professor Hans, or Professor David Hans. My full-time job, and the one that I show up in person to, is actually as an assistant professor of physics and chemistry, and also occasionally biology here and there at Luzerne County Community College. I've also had online experience, namely currently at Lackawanna College, where I also teach online biology. Incidentally, today marks the start of the second summer semester for Luzerne, Lackawanna, and Salus. So I just went from 0 jobs to 3 all in one day. In any case, I have a background. For the past 10 years, I've been in college, except for the year 2020. That would have been the only year where I was actually no longer a student. Over the years, I've gotten my associates in chemistry and biology, a bachelor's in biochemistry, and a master's in chemistry. That was essentially a direct continuation of kindergarten through 12th grade straight on to my master's. And the year 2020, I took a break from all that just to teach. But since a position for chemistry and physics opened up, in order to formally keep it, I had to get some additional graduate credits in physics. I took that postmaster's for 1 year and finished that in 2022. And now I am working on my doctorate in health science. And I am loving it and looking forward to finishing off my career as a student by 2026. Lord willing. Well, in any case, this will just be a little general breakdown. As far as lectures go, your lectures will be presented as asynchronous videos, and the PowerPoints and PDF versions of those slideshows, as well as the videos, are all available on Blackboard Learn, or ecampus.salus.edu. Each week you'll have a quiz, which is really just a worksheet that you'll fill out or you'll write answers to on a separate sheet of paper, and then you'll upload a picture, an image, or a scanned copy of your work to Blackboard Learn. And starting with week 2, you'll start having exams, which these are going to be not worksheets, but they're going to be multiple choice questionnaires, or there'll be some questions where you fill in a calculated answer. For example, some questions on your exam may ask you choose what answer A, B, C, or choose all that apply, A, B, and or C, D, whatever. Whenever you have to calculate an answer on an exam, you'll be told what units your answer is supposed to be, but do not write the units in your answer submission. Essentially, if you're told calculate the force in newtons for this particular problem, and you determine that the answer is 90 newtons, just type in the number 90 and do not write 90 N or 90 newtons, just write the numerical value. You'll be told what units you're solving for, that way you know what numerical value you're trying to find, whether it's kilograms, grams, whatever. Just don't write the units for your exams. Recitations, formally these will be on Wednesdays and Fridays from 10:30 to 11:30 a.m. Eastern. In reality, how this will go is on Wednesdays, we'll have a session where we're going over the quiz material because I understand that many of you most likely do not have a bachelor's in science or a versatile background in physics per se, biology or chemistry. I'm not going to assume that. Therefore, the quizzes, they're mainly going to be things that we work on together, and your exams will be what you work on your own. For quizzes, these will be worksheets, and we'll work on going through the problems. If they're math intensive, I'll demonstrate how to solve those types of problems on Wednesday. And if we don't finish up the quiz on Wednesday, then that will carry over into Friday. If we do finish discussing the weekly quiz on Wednesday, then on Friday, that'll just be essentially ask questions beforehand. And if there are any questions, we'll have a session together. And if there aren't, then I'll still be available to answer questions by Blackboard Learn Messenger or email. But the main one will be on Wednesdays, where we're going over how to solve the quiz before you actually submit it. Since you have orientation tomorrow, normally we'll only have one recitation period this week, so this one today will be the recitation for this week. Normally it would be actually after orientation, but I would like you to get everyone acquainted with the class as early as possible, which is why we're doing recitation today. Now, as far as Blackboard Learn, there's mainly 4 main tabs. There's the announcements tab, which will occasionally have announcements which I believe are set to actually go to your email as well. They'll not be every week per se, but maybe occasionally. The course syllabus, that's where you can find a Word document or PDF version of the syllabus. If you click on a Word document link in Blackboard Learn, it automatically downloads it. Same thing with PowerPoints. That's why I'll have PDF versions of our lecture slideshows and your syllabus, because a PDF usually automatically shows up in a new tab on your browser or on your current tab. That way you don't have to download it every single time you click on the link. The course documents tab is going to be the most important. That's going to be the location of all the video lectures as well as the relevant slides in both PowerPoint and PDF versions. And that's also where you're going to see your weekly assessments, which will be your quizzes, your quiz worksheets, and your exam questionnaires. See the current week for relevant due dates of those assignments. Most assignments are usually due on a Sunday. Your final exam will be due earlier in the week when that is available. As the weeks go on, new weeks will become available. So right now you should only see week 1 material. There will also be the Blackboard Collaborate tab. This is where we're going to have our recitations. As far as I'm aware, the videos will be available to view again after the recording session is over. That way, if you're not available that week for that session, you should still be able to come and see it. Going over into how this week is going to be, how the weeks are going to go, we formally have a 5-week lecture course, with the 6th week being the final exam. For weeks 1 through 5, each week of lecture, you'll have 1 quiz worksheet that is due by the end of the week or Sunday night. The quiz will just cover that week's material. So quiz 3 will just cover material from week 3. Quiz 1 only focuses on material from week 1, and we'll go into that in a few slides in this slideshow. Starting with week 2, you'll be having an exam. Now, in week 2, you'll have exam 1. Exam 1 only covers material from week 1, not week 1 and week 2. In week 3, you'll have quiz 3, which covers material from that week, and you'll have exam 2, which covers material just from week 2. The point is, the quizzes will be where you have your most intensive math problems, and we'll work on those usually together through our recitations. That way you can build up the skills, and your exams, they will just be, you will be tested on the current week's material in the following week's exam. That way you have an additional week to study the past week's material before it shows up on your exam. Like quizzes, the exams will be due on Sundays. The only cumulative exam will be your final exam, which I believe, I'm not too certain yet on what the end of the semester due date will be. Currently, the final exam is going to be the 6th week due anytime between Monday and Wednesday. That might change depending on what the actual final date of the semester is, but it'll definitely be at the very least due by the Monday of the 2nd week of August. So just as a recap, your quizzes are the ones that are going to be worksheets that will be heavy on math. We'll work on those together usually, and each quiz only covers the current week's material. Each exam has multiple choice or fill-in answers, and they're not all math intensive. Many exams will have mostly multiple choice questions, maybe an occasional math problem here and there. I believe exam 2 will be the only one that's predominantly math heavy, but you'll already see much of that stuff during the 2nd week of quiz 2, with quiz 2. So week 1 material will show up on quiz 1 and exam 1. Week 2 material will show up on quiz 2 and exam 2. Week 3 material will show up on quiz 3 and exam 3, so on and so forth, with the final exam being the only one that is cumulative. Because of the topics that we'll be covering, your 5th week will actually be not too math heavy, except for exam 4. The 5th quiz will actually just be looking into differences and similarities between different types of imaging, like mass or magnetic resonance imaging, computed tomography or computed axial tomography, CAT scans, PET scans, radiography, x-rays, some things like that. So quiz 1 through 4, lots of math. Exam 1 through 4, lots of math. And the final exam, there'll be math as well. Well, mostly these will be on, most of these are just, most of the exams will just be on multiple choice knowledge information. And for quizzes and exams, by all means have your PowerPoints or slideshows out, have the videos out. There's no issue with that. This course is not meant to test you on your prior knowledge, but just on your ability to use knowledge that is already widely available. So have your slideshows out, have your notes out while you're doing your exams and your quizzes. No issues with that. And just do your best to apply the material. That is all you're being tested on. Or that is my goal. So this week starts on a Wednesday. And your final exam will be on a Monday, perhaps a Monday through Wednesday. For most other weeks, so week 2 through week 5, here's a little guide. Monday through Wednesday, watch the lecture video, read through the slides, just slowly make yourself familiar with the information. Then on Wednesday, we'll have our recitation, which will be geared toward going over an exam problem or two. And by Wednesday or on Wednesday, print out your quiz, start working through those problems on your own. And if we didn't finish the quiz on Wednesday, we'll do so on Friday. And by then, try to finish the quiz yourself as well. It's still due by Sunday, but for weeks where we have an exam, try to leave the weekend for the exam. Or you can do that earlier, since the exam is meant to cover material from the prior week. So Monday through Wednesday, before our first recitation of the week, glance over the lecture material, maybe do your exam for the prior week's material. Then between Wednesday and Friday, work on your quiz for that week in tandem with the recitation video or videos. And if you haven't done your exam by then save your exam for afterwards. That's just a good little guide. A helpful website is wolframalpha.com. This is useful for solving many of our math problems. For example, if you have to solve anything that uses a trig function like sine or cosine, and you don't have a calculator, whether you do or don't, just know that trig functions can be solved in two types of units that you have to tell the calculator what unit you're using. It's either degrees or radians. In your calculator, you would have to find where the setting for degrees is. If you use Wolfram Alpha, just type the trig function, put parentheses, type the angle, and then type the word degrees. For example, to solve for the value of the sine of 60 degrees, I typed in sin, parenthesis, 60, space, degrees, end parenthesis. Doing that tells Wolfram Alpha we want to solve the sine function using degrees and not radians. And then it will give you, if there's an exact value, it will give you a fraction, which in this case is the square root of 3, all that divided by 2, or the decimal answer is 0.866 down to a bunch of decimals. When you're solving your math, try to use the exact answer so as to avoid rounding issues until your final answer. But if it can't be avoided, try to have your answers out to maybe 6 to 8 decimal places to avoid any rounding issues. Now, if you're going to use your inverse tangent function or arctan, that's when we try to solve for an angle. Well, formally, that's going to be arctangent of your y value over your x value. And just to demonstrate that for Wolfram Alpha, type arctan, parenthesis, your y value over your x value, end parenthesis. Wolfram Alpha will tell you what it thinks you were trying to type, which tan inverse of our sides of our triangle or our vectors. And then it'll give you either an exact answer or an approximated decimal answer. But most importantly, for this type of stuff, it will give you the angle all the way at the bottom, which arctangent of 45 over 82 is just an angle of 28.76 degrees. Some other math. Let's say you want to take the square root of some value. Like for example, if we're trying to find the resultant vector of its after we already find its x and y components. Well, a squared plus b squared equals c squared, solving for c. We would type in sqrt to represent square root, then put beginning and ending parentheses so that we're telling Wolfram Alpha what to take the square root of. And then on the inside, what I have is square root parenthesis -6 end parenthesis caret 2 that says take the square or square what's inside of it. So if one of our vectors is -6 and the other is 8, make sure that the negative sign is in its own set of parentheses so that we have the square root of -6 squared plus 8 squared. And if you type all that in, Wolfram Alpha will give you the exact answer, which in this case is 10. Now let's say you want to get an exact answer for your arctan function, and you had a bunch of vectors with angles that all gave decimal places, and if you want, you can go out to 8 decimal places and plug in their values, or you can just plug in their exact values, which in this case we had one vector, which was 20 sine 30 degrees, and we have another y vector that's 12 sine 60 degrees. They're both positive, and we add them together. For our x vectors, let's say we had 2 x vectors. To solve for our resultant x vector, which is, in this case, one x vector was positive 14 cosine of 60 degrees, and the other one was -6 cosine 30 degrees. Well, put all that in parentheses, add them each together, the negative sign just becomes a minus. In other words, this mess all the way in the top search function for Wolfram Alpha gets interpreted as the arctangent of 20 sine 30 degrees plus 12 sine 60 degrees, all over 14 cosine 60 degrees minus 6 cosine 30 degrees. And Wolfram Alpha basically can reduce that a little bit more. And furthermore, it will give you a decimal approximation of your answer in radians, but most importantly, the degree is what we're looking for in this case, 84.94 degrees. So you would probably get that solution for your exam if you were given this type of problem. Try to type in the exact values like 20 sine 30 degrees or whatever, but you can still try to use out to a certain number of decimal places and just plug in those values instead of 20 sine 30 degrees or 12 sine 60 or whatever. This is just one way to show how to get the most possible, the most exact answer for, say, an exam where you have to type in your numerical value. Whereas for quizzes, you don't need to worry per se. You can go out to a certain number of decimals. I'll be looking at your quizzes instead of them being automatically graded by the software. That way I'll still be able to see if your answer is relatively close or you did your math correctly. Basically, show your work that way. It helps me follow what you did, just in case your answer is slightly different or very different from the answer that I got. Now then, that's for using Wolfram Alpha. And you're welcome to use your natural calculator if you prefer, or a different solution solving software. Let's say we have the following quiz. Well, one of your quizzes is going to involve you looking at motion time graphs. There are actually three types: position versus time, velocity versus time, and acceleration versus time. And the slope of position versus time is how we get our velocity values, and the slopes of velocity versus time is how we get our acceleration values. So for these types of problems, you'll just have plots that have straight lines. That way it's easy to calculate the slope of each straight portion of our graph, which is just the second y-coordinate minus the first, all divided by the second x-coordinate minus the first. That will equal the slope. So let's look at part one of your quiz. Question one is going to be, using the velocity versus time plot above, sketch the acceleration versus time plot. What would it look like from t equals 0 to 8 seconds? Well, since acceleration is derived from velocity versus time, we need the slopes of our velocity versus time plot. So for each linear region, just calculate the slope. In other words, from 0 to 1 second, that's our first straight line portion. Well, what we look at here is our second coordinate has a y value of 2 meters per second, and it has an initial coordinate of 2. That's where we get our numerator in units of meters per second. Our x-coordinates, the final x-coordinate is 1, and the initial x-coordinate of this linear region is 0. So 1 minus 0 seconds. Therefore, what we get is 0 over 1, or 0, and the units of meters per second divided by seconds is meters per second squared. Let's look at something that isn't just a horizontal slope. Let's say this slope right here, that is longer than a single second region. Well, we still care about the initial coordinates and the final coordinates. Our final y value for that slope is -8. Our initial y value is +8. So -8 minus +8, or -8 minus 8 meters per second. The x-coordinates would be 6 seconds minus 4 seconds. Therefore, we get a slope or an acceleration value between the times of 4 to 6 seconds our acceleration equals -8 meters per second squared. And you'll just do that for each linear region, find the slope. Now then, for the first part, after we get all of our slope values, what we find is from 0 to 1 seconds, our acceleration value is 0 meters per second squared. From 1 to 2 seconds, we should get a +6 value for acceleration during that between those two times. That's why we have one line filled in on our acceleration versus time plot at +6. And then from seconds 2 to 4, we have an acceleration of 0. And then going on, just complete the graph from there. Acceleration in meters per second squared, time in units of seconds. These dotted lines are meant to say we're instantly going from one portion to the next, or we're having a discontinuous set of slopes from our velocity graph. The last part would be, using our acceleration versus time plot, calculate the magnitude of the net force acting on our object at certain time ranges. For this, we're going to assume that our object has a mass of 35 kilograms. Well, as you'll see in the lecture video, force is related to mass times acceleration. So what we need is, since we already know the mass, we need to know the acceleration at those specific points in time in order to find the force. So if you asked, what's the force at 0.5 seconds? Well, let's just see what the acceleration equals at 0.5 seconds. Well, what we got from the slopes of our velocity versus time as we were making our acceleration graph, any point in time between 0 and 1 seconds, whether it's 0.75, 0.3, doesn't matter. It's on this portion where we calculated 0 meters per second squared. Therefore, force at 0.5 seconds equals 35 kilograms times 0 meters per second squared, or 0 newtons. Let's say we go at, say, what's the force on that 35 kilogram object at 5 seconds? Well, it doesn't matter that we are using time equals 5. It could be 4.9, 5.136. What matters is we're looking at a point of time that is related to this value here. So acceleration is always -8 between these two times. 5 seconds is between that time range. So we're going to use acceleration equals -8. So at 5 seconds, the force equals 35 kilograms times -8 meters per second squared, or -280 newtons. Mass is a scalar, it just has a magnitude. It's not negative for this class. Acceleration is a vector, it can be positive or negative. Therefore, the sign of acceleration tells us the sign of force, because we had a negative acceleration at 5 seconds. It has a negative force. Now, that's the first problem. Second problem, just as standard, you have multiple vectors and you want to find the resultant vector. Well, the easiest thing to do is to break these starting vectors. Vector force 1 of 24 newtons, 80 degrees below the x-axis, pointed to the right, and vector force vector 2, 35 newtons of force with a magnitude of 35 newtons at an angle of 30 degrees above the x-axis, pointing to the left. Step 1, determine the magnitude and the angle, or Fr and theta r, of the resultant force of F1 plus F2. Because these initial forces are not parallel, you can't just add up their values, 24 plus 35 or 24 minus 35. You can't just do that. We have to break them up into their x components and their y components. So the x component of force 1, or F1x, is going to equal the total magnitude, 24 newtons. And because this is an x component, we're going to times that by cosine of 80 degrees. And because this force arrow is pointed to the right, that is the positive x sign, so we'll multiply by +1. Wolfram Alpha might give you an exact value. You could just use +24 cosine 80 later in our problem if you'd like, or just go out to a bunch of decimal places, 4.167556 newtons. Now the x component of our second force would be its total magnitude, 35 newtons, times cosine of its angle, 30 degrees. And because this force arrow is pointed to the left, that's the negative x side. So we're going to multiply by -1. Therefore, what we get is an exact value of negative 35 square root of 3 divided by 2, or approximately negative 30 to a bunch of decimal places, which if we add up our 2x components, we have 4 plus negative 30, that's approximately negative 26.143332 newtons, and that would be the x component of our resultant force, what we're trying to solve for. Similarly, we have to do the same for our y components. So F1y, take the diagonal magnitude of force 1, 24 newtons, times our sine function of 80 degrees. And because this vector is pointed down on the y-axis, that's the negative y-axis, why we have this times -1 here. And then the second y component, well, take 35 times sine of the angle, in this case 30 degrees, and because this angle is pointed up, or it's in the positive y quadrants, we'll multiply by +1. And that equals positive 17.5 newtons. Adding up all of our y component vectors gives us the component of our y component of our resultant, approximately -6 newtons out to a bunch of decimals. All right, we have our x component of our resultant and the resultant's y component. So, going from there, what we need to solve for the resultant's magnitude is take the x component in parentheses and square it, and then add to that the y component in parentheses raised to the power 2. And what that all equals, take the square root of it. Practice solving this on Wolfram Alpha or in your calculator. You already have the final answer, so practice solving it just to see if you still get the right answer. That way, for when you see something like this on your exam next week, you'll be confident in knowing how to properly type in everything. So the square root of the x component squared plus the y component squared is approximately 26.9 newtons. For your exams, just type in honestly as many decimal places as you get, up to like maybe 6 to 8. I'll have a range of correct values for your exams so that you'll still get a correct answer as long as you do everything right. And I'll tell you what units it should be, but just don't write the units on your exams. Definitely do that for your quizzes though. Now for the angle, we would type arctan, and we would have our y component divided by our x component. If either of these are negative, put it in parentheses. That way we have arctan of parenthesis, -6, yada yada, end parenthesis, divided by parenthesis, -26, end parenthesis, end parenthesis. And what you should get if you type that out correctly, and if your calculator is in degrees instead of radians, you should get 13.21 degrees. For the part where you're asked to sketch the resultant vector, pretend you have your xy coordinate grid. What we have for our resultant is a negative x component, so just draw a vector arrow pointing to the left if it's a negative x. We also had a negative y resultant value, so from the arrowhead of the x component, draw a downward arrow for your y. And then from the tail of your first vector to the arrowhead of your second vector, draw your diagonal or your resultant vector. That way you have the correct direction, which you'll add your angle, 13.21, and you'll add the value of this length, f sub r, or v sub r if it's velocity, a sub r if it's acceleration, F just stands for force, equals 26.9 newtons, or whatever your value you want, if you go out to a certain number of decimals. In any case, that would be that problem. And then for the last one, this one's actually going to be pretty straightforward. We're looking at basic torque problems, and we're not going to be concerned about the gravity of our actual object, just the forces acting on that object, which is not always true in real life, but it's true enough for simple setups. Let's say we have some bar. Let's say we have some bar that has a total of 20 meters across, and it can rotate at the point marked by X. Here's where our bar can rotate. There are two weights on that bar. Weight 1, which is 50 newtons, or also labeled A, and then there will be some force of gravity or some weight of weight number B, also called hanging mass B. Well, and because the bar is tilted, we're going to essentially have our weights, or the force of gravity for each of these weights, pointed straight down, but at an angle of either 30 degrees or 150 degrees, whichever side you want to use. The larger angle or the smaller angle does not matter for sine, but for the sine function, this will make more sense as you watch the lecture video. These recitations are assuming you've already watched those, which I know you have not on the very first day of class. But anyways, watch the lecture video, then get back to the recitation afterwards. What we care about is the distance this force is pulling from our rotation point, the angle it's pulling, and the amount of newtons it's pulling. And same thing for force B. Well, we're assuming that this bar is at static equilibrium. That means that the amount of weight, the torque that this weight is pulling with, is enough to neutralize the amount of weight, the amount of torque that hanging mass A is pulling with. So kind of easy to solve for the torque of A because we know its weight and we know its distance from our point of rotation. We know that this distance right here is 17 meters, and this distance that we're not using is 5 meters. So 17 minus 5 gives us a 12-meter distance between where our force is in contact and where our bar can rotate. So torque of A equals the force vector cross product the distance vector, or 50 newtons, times a distance of 12 meters times sine of the angle between those two, or sine of 30 degrees. You could also use 150 degrees, because for sine functions, it does not matter which complementary angle you use. That's why you give them both the larger angle and the smaller angle. This positive 1 here, because we're dealing with a torque and not a force, we're not thinking of left, right, up, down. That's translational or linear motion. We're thinking of counterclockwise or clockwise. Well, as we look at torque A, if we follow that force, which is pointed straight down, and then we start moving toward our point of rotation, what we see is we're turning counterclockwise, which is a positive torque, so we'll multiply by positive 1. Solving all this, we get positive 300 Newton meters. For torque B, we don't know its force value, but we know its distance is 3 meters away from our point of rotation, and the angle is going to be 150 degrees. When it comes to hanging masses, it is a force of gravity, which is always pointed straight down. So our force is pointed straight down. If we start moving toward our point of rotation, we have a clockwise rotation, which is a negative torque. So that's why we have a -1 value here. And what we get is torque B equals -1.5 times the value of force B. Therefore, since the net torque is going to be torque A plus torque B equaling 0 newtons, torque B is negative, so we have 300 Newton meters. minus 1.5, force B, Newton meters equals 0. Just solve for force of B. That'll be 300 Newton meters divided by 1.5 meters, or 200 newtons. And that would be your final answer for problem 3. The math part. Now, furthermore, if A is considered the resistance force and B is considered the effort force, what is the level of what is the lever class? What is the lever class of this system? Well, you can have a class 1, class 2, or class 3 lever. It really just depends on where are the resistance and effort forces located relative to our fulcrum or our point of rotation. Since we have our resistance on one side of our fulcrum and our effort on the other side, this would just be a first class lever. Let's see. Quiz help. In any case, that would be the end of our first week recitation. This also covers the first quiz. Try working on that. For Friday, we're likely not going to have recitation because it is the first week. Essentially, come around, ask for questions. I'll be able to respond to Blackboard Learn messengers or emails if you have questions. And if there's any big concerns, we can definitely have a recitation video session again on Friday. But in essence, look through the lecture video and the slides, work on the quiz by Friday, have any questions already sent to me if you have anything. And if needed, we can start a video session again. Not necessarily at 10:30 a.m. The times are flexible since this is an online class. However, essentially, this will be the only planned recitation video for this week. Hope you all do well. Hope you all enjoy your orientation tomorrow. I imagine it'll be in person. And since I am well above Philly, where most of you probably are, hope you all are enjoying your time. Would love to hear what the campus is like and how you're doing. And yeah, peace.